Hello friends, today we are going to start our second lecture on trigonometry. My name is Majid Ali. Our topics that we will be covered in this video is here that first we discuss about the trigonometric functions. After that we will discuss the trigonometric identities. We often call these identities with another name that Pythagoras identities, and at the third number we will discuss about sign of the trigonometric function, that what sign be with any trigonometric function. Next we will learn about the value of the trigonometric functions, that how to calculate the values of the trigonometric function. In this topic we learned a trick that how fastly we learn the trigonometric values, that how to find the trigonometric values. First of all, we discuss here the right angle triangle. As in the previous video, you have to remember that we will see that there is two fundamentals of triangle. First is angle trigonometry, sorry. There are two fundamentals of trigonometry. First is angle, second is triangles. So in the first lecture we covered about the angle. Now here is the second fundamental of trigonometry, that is triangle. And we are studying here right angle triangle. Any triangle with one right angle. What do you mean by right angle? Right angle mean that two sides that form 90-degree angle, that is called the right angle, and the other two angle must be acute angle. What do you mean by acute angle? Here is its definition. By the meaning of what is the meaning of acute angle: a positive angle with the measures less than 90 degree is called acute angle. Now you have to uh, now you have to clear that definition, that what is the meaning of acute angle. Acute angle must be less than 90 degree. It is from 0 degree to 89 degree, but not equal to 90 degree. This is the definition diagram of the acute angle. As we know that this is the initial side and this is the terminal side, and this point is the vertex. And if the terminal side subtend an angle less than 90 degree, then we call it an acute angle. And here is the diagram of the right angle triangle, that you can say here that A side and B side form a right angle. This sign is for using the right angle. This is for using the right angle. And the other two angle, if you measure that both angle A and angle B, both angles are acute, mean less than 90 degree, because we know that the sum of the angles of triangle is 180. In other words, we say that angle of theta, angle A, angle B and angle C. If we sum three angles, then its sum is equal to 90 degree. So here is we have 190 degree, then it must be less than 90 degree. So that's why we call in the we say in the definition that two angles must be less than 90 degree. Here is some trigonometry function, that is our first topic. Let us consider the right angle triangle ABC. This symbol is used for the triangle with right angle at C. It means that we have formed an angle at this corner C of the triangle of side A, B, C, as shown in the figure that we have here. Figures that the right angle, as we mention here, the right angle at point C, and here is the right angle at point C, and both angle must be acute angle less than 90 degree, angle B and angle A. Now here is we come to know about the some important names, that if the right angle, the opposite side of the right angle is always known as hypotenuse, mean this is the right angle and its opposite side is this one side C or AB side. This is known as hypotenuse. And the angle which is, and the side which is opposite to any angle, this angle is known, this side is known as the perpendicular or altitude, and it has another name which name is perpendicular. And if the side that is along the theta, along the angle, this is known as the adjacent side or base side, and these sides are in shortly represented by HYP for hypotenuse, ALT for altitude, OPP for opposite. We also name is at opposite side, PERP for perpendicular, because we give its three names like altitude, perpendicular or opposite, and here is its name is adjacent for ADJ and base. Now here we see that there are six ratios that is be found by using the triangle. First ratio is, you can see that A over C, A divided by C, A side divided by C side. Next is B side divided by C side, and third is A side divided by B side. This is the three side, and three is the reciprocals. First is C over A side, C divided by A side. C over B means C side divided by B side, and third is last is B side divided by C sides. These ratios are depends on the size of an angle, not on the triangle formed. That's why those ratios are known as trigonometric functions. As we know already that function has one dependent and one independent value, so here is these dependent values only depends upon the size of the angle theta. So we give all the ratios with the specific name. Here is the some specific name. The first ratio that we called A over C, which is equal to sine theta. Second is second ratio B over C, which is known as cos theta. Third is A over B, which is known as tangent theta. And fourth ratio that we have C over A, reciprocal of the A over C, which is known as cosecant theta. Fifth ratio that we have the reciprocal of B over C, which is known as the secant theta. C over B, hypotenuse over base. And the last is the reciprocal side of the tangent, cot theta. B over A, base over R. Now we see that the sin theta is equal to altitude or opposite over hypotenuse. Next, base or adjacent over hypotenuse. Next is altitude over base or hypotenuse over adjacent sides. And these three are the reciprocals identities that we will see in next slides. Trigonometric functions of any angle. We start with an angle theta. Here is not for you, it is here theta in standard position, and choose any point P have coordinate x and y. This is talking about in a coordinate system, Cartesian coordinate system xy, that any point P has xy on the terminal side of an angle theta perpendicular from the from point P to the x-axis at point Q. Determine a right triangle Having vertices at O, P and Q, we find the distance r from pxy to the origin 0 0 using the distance formula. What do you mean by this paragraph? Here we say that at any point, this is the point P whose coordinate is x and y, and if we join the point P with respect to origin, then we form a side which is we call the R, which we call it R. So here, from here we draw a perpendicular on the x-axis that intersect at the point Q. Here we know that come to know that there is a 2 points. First is x and second is y. It means that the along the x-axis we have a x point, and along the y-axis we have a y point. Now at the end we want to find the distance between point O and point R. We use the distance formula, which is equal to, this is the distance formula. D stands for distance formula from O to P, which is equal to x2 minus x1 square plus y2 minus y1 square whole square root. By substituting the values, that here is we only have a 1 values x1 and y1, which is equal to x and y. So x2 is only x minus 0 plus y minus 0 square under root, which is equal to x square plus y square square root. Now all the trigonometric function now defined in the form of distance formula, that already we know that here altitude, this is the angle theta, this is the angle theta. The opposite side of angle theta is known as altitude, as we have seen, and name of the altitude is y. So y over r. What do you mean by r here? The opposite side of the right angles of the right angle. So this is known as hypotenuse, and we name the hypotenuse as r. So sine theta is equal to y over r, cos theta is equal to x over r. It means adjacent over adjacent over hypotenuse, and the value of adjacent is x and hypotenuse r. Tangent theta is equal to, in the previous slide we see that altitude over base or adjacent, altitude over adjacent, so y over x, and these three values are obtaining by reciprocaling the three values, that cosecant theta is r over y, secant theta is r over x, and the cotangent theta is x over y. Now we will solve some example related to this term. Here is the example 1. What is the example 1? This is the terminal side of an angle theta in standard position passes through the point 8, 5. Find the values of the 6 trigonometric function. First of all, you have to know that the point that we see in the previous slide, that point P means P, and 8, 15 mean this is the value of x and this is the value of y, and we here compare both values, that 8 is equal to x and 15 is equal to 8. By using the distance formula, we know that distance formula is equal to r is equal to square root 8 square plus 15 square, which is equal to the square of 8 is 64, and square of 15 is 225. Square root, by adding both 289, the square root of 289 is 17. Now substituting all the values in our trigonometric functions, that sine theta, we already seen that y over r, the value of y here is given 15, and we calculated r here is 17. So sine theta is 15 over 17. Cos theta, which is equal to x over r, mean 8 over 17. Here is the value of x and here is the value of r. 8 over 17. The value of tangent theta, which is equal to y over x, means 15 over 8. The cosecant theta is r over y. Mean r, this calculated value r, and this over value y. 17 over 15. Secant theta, which is equal to r over x, mean here is the value of r and here is the value of x. 17 over 8. Cot theta, and we can also determine these values by reversing these values, as you are seeing that this is the value 15 over 17 and this is the 17 over 15. This is value 8 over 17 and this is 17 over 8. This is 15 over 8 and this is 8 over 15. If you determine these three values, sine, cosine and tangent, then we can also determine these three values by reciprocaling these three values. Here is the example 2. This is similar to the previous example, that a terminal side of an angle theta in standard position passes through the points -3, -4. Find the values of 6 trigonometric function. Similarly, this is the value of x and this is the -4 is the value of y. Substituting the values in distance formula, -3 square plus -4 square, which is equal to 9 plus 16, which is the, by adding both 25, the square root of 25 is 5. Now again substituting the values in the values, that sine theta is equal to y over r. Here is the given value y and we calculated the value r, which is -4 over 5. Cos theta x over r, we have the value of x -3 over 5, the value of r. Tangent theta, which is y over x, we have the value here y, which is -4 and -3, which is equal to -4 plus 4 over 3, and other three values can be calculated by reciprocaling these values, which is 5 over -4 and 5 over -3, and this is 4 over 3 and this is 3 over 4. Our next topic is trigonometric identities. If you have any question related to the previous example and topic, then comment below. Uh, Before going to study trigonometric identity, first we look at the Pythagoras theorem. What do you mean by Pythagoras theorem? Pythagoras theorem means that the hypotenuse square, this is the value, as we already seen that the opposite side of right angle is hypotenuse. The opposite side of angle theta is adjacent or opposite or perpendicular, and the side along the theta is known as the base, which is equal to this one. And we say that Pythagoras theorem is stated as the hypotenuse square is equal to altitude square plus base square. Here is the statement of Pythagoras theorem, that hypotenuse, which is equal to c, so hypotenuse square c square. Altitude, which is equal to a, here is the altitude a square. Base square are adjacent. We have two name here for the value, the for the side b, or base, or we can also say that it adjacent side. C square is equal to a square plus b square. There are three fundamental identities of the trigonometry as given below. These identities also have another name. These identities are also known as Pythagoras identities. Pythagoras identities. First is sine square theta plus cos square theta, which is equal to 1. We will, we will be proof in next slide that identity. One second is 1 plus tan square theta, which is equal to secant square theta. Third is 1 plus cot square theta, which is equal to cosecant square theta. Now here is the proof of first identity. As we have to know that Pythagoras theorem, which states that hypotenuse square, which is equal to altitude square plus base square. Now dividing the equation 1 by c square both side, then c square divided by c square, here is the c square divided by c square, and a square divided by c square. because we are dividing c square on both sides, left hand side and right hand side. A square over c square plus b square over c square. Here c square cancel out with c square, we have only 1, and see that a over c, altitude over hypotenuse, which is equal to sine theta. Here is the square of both sides, so if we convert a over c into sine theta, then the square is also with it, sine square theta. And b over c, see here, b over c which is equal to cos theta, that base over hypotenuse or adjacent over hypotenuse, which is equal to cos theta. So here is the square, so cos square theta. This is the proof of the first identity. Now you can also prove that the other two identities by dividing the Pythagoras theorem, that we divide it here for the first identity of c square. For the next two identities, you can divide it by a square and b square. The other identities is left for you to prove them. Reciprocal and quotient identities, as in the previous examples, we already seen that sine theta is the reciprocal of cosecant theta, or cosecant theta is reciprocal of sine theta. Cos theta is reciprocal of secant theta, and secant theta is reciprocal of cos theta. It is the vice versa. Tangent theta reciprocal of cotangent theta, and cotangent theta reciprocal of tangent theta, and these are also vice versa. These two identities are the quotient identities. Tangent theta, which is also equal to sine theta divided by cos theta, this is the first quotient identity. And cot theta, which is equal to cos theta divided by sine theta, this is also the second identity, quotient identity. Here we will discuss the sign of the trigonometric function. As we know that we divide the Cartesian coordinate system into four quadrants. This is the one quadrant, first quadrant, second quadrant, third quadrant, fourth quadrant. We name these quadrants according to the rotation of anti-clockwise of any angle theta. As we know that the angle is positive if the terminal side rotates anti-clockwise. So by using the anti-clockwise rotation, we name these quadrant, that this is the first quadrant, this is second, this is third quadrant, and this is fourth, because if we rotate an angle, a terminal side, let's see here, from here we start the rotation, that this is first quadrant, and in then second quadrant, and in the third quadrant, and at end fourth quadrant. Here is a trick to remember the sign of the trigonometric function by the sign of x and y in the quadrant in which the terminal side of the triangle lies. As you can see that in this quadrant, this is the first quadrant, x is positive and y is also positive. This is second quadrant, in this quadrant x is negative and y is positive. And here in the third quadrant, x is negative and y is also negative. And here in fourth quadrant, x is positive, y is negative. So in here we can see that if the value of x greater than 0, it means x is positive, and y, the value of y greater than 0, it means y is also positive. And remember that r is always positive, it is never be negative. Remember that. In second quadrant, here in the figure you can easily understand that all the functions are positive in the first quadrant. How? As already we know that x is positive and y is positive, and here x is negative, y is positive. Here only sine and cosecant is theta is positive. Why? Because we know that sine theta is equal to y over r, y divided by r. So y is positive, r is also positive, so sine theta is positive. In the third quadrant, we know that x is negative here and y is also negative here. So in both cases, x is also negative, y is also negative, less than 0, less than 0. So the value of tangent and cotangent is positive. And in the fourth quadrant, we know that x is positive, y is negative. So we know that cos theta is equal to x over r. So x is here positive, r is also positive. So x over r mean cos theta and its reciprocal identity secant theta is positive. So you can also remember that in other trick that here is all in first quadrant all positive. Remember that it's first word a, here is first word s, here is first word t, and here it's first word cos. So this is also known as the cast rule. Cast rule mean first is c, here a, here s, and here is t, cast rule. This is the easy way to remember that the cast rule. Cos, C stand for cos, A stand for all, S stand for sine theta, and T stand for tangent theta. And if we remember this rule, then we can also be remember the sign of the trigonometric function, that which sign is belongs to which value. Trigonometric function values. Here we will discuss only the trick that how to determine the trigonometric values. There is a many tricks, but this trick is very useful and easy to use. First, write down the counting from 0 to 4. 0, 1, 2, 3, 4. Next, divide the all values divided by 4. Here 0 by 4, 1 by 4, 2 by 4, 3 by 4, 4 by 4. Next, simplify them. 0 over 4 is equal to 0, 1 over 4 as it is 2 over 4 by cancelling. 2 ones are 2, 2 twos are 4, 1 over 4, 3 over 4, and 4 cancel out with 4, which is equal to 1. Now, square root all these terms. 0 square root is equal to 1 over 4 square root, 1 over 2 square root, 3 over 4 square root, and 1 square root. Now again simplifying, square root of 0 is 0, 1 square root 1, 4 square root 2, 1 square root 1, 2 square root 2, 3 square root as it is, 4 square root which is equal to 2, 1 square root is equal to 1. So remember these steps. First step is writing down the counting from 0 to 4. Next, dividing the all values by 4. Then after that, square rooting all the values. Then the obtaining values, we have the only values for the sine theta. This is for the angle 0, this is for angle 30 degree, this is for 45 degree, this is 60 degree, and this is angle for 1 degree. This is the value for the first quadrant 0 to 90 degree. The other values can be determined by complementing the value of sine theta, as we know that sine theta and cos theta both are the complement angle of each other. And the value of tangent can also be determined how, by dividing the sine theta divided by cos. As here you can see that the values that we obtained written here. First is 0 for 0 degree, 30 degree, 1 over 2, 1 over square root 2 for 45 degree, square root 3 over 2 for 90 degree, and 91 for 90 degree. All these values only for the sine theta. So how we will obtain the value of cos? By reciprocally complementing the value of sine. That sine is 1 at 90 degrees, so cos is 0. So value of sine at 60 is equal to the value of cos at 30. At 45 both values are equal. The value of sine at 30 degree is equal to the value of cos at 60 degree because sine 30 and cos 60 are complement to each other. The value of sine 0 is equal to the value of cos 90 degree. The value of tangent can be obtained by dividing both 0 over 1 which is equal to 0. 1 over 2 divided by square root 3 over 2. We cancel out 2 by 2 which is equal to 1 over square root 3. Here is not the square root 2. Here is some little bit mistake that 1 over square root 3. The value of tangent 45 which is both cancel out with this one which is equal to 1. And dividing the value both these values we have square root 3 as here square root 3 this is also here square root 3 here is some mistake, so 1 over 0 cannot be defined, so tangent 90 degrees is equal to undefined values. We get these values of the other three values by reciprocaling these trigonometry. As we know that the reciprocal of sine theta is cosecant theta, the reciprocal of cos theta is secant theta, the reciprocal of tangent theta is cotangent theta. Remember that the first quadrant is from 0 degree to 90 degree, second quadrant is from 90 to 180 degree, third quadrant 182 to 70 degree, and fourth quadrant to 70 to 360 degree. Here is some examples that we will be solve for our theory. Find the sign of the trigonometric function that trigonometric function of an angle in standard position with the given measure. First is angle 300 degree, as we know that the 300 degree lie in the fourth quadrant. So in fourth quadrant only cos theta and secant theta are positive. Remembered that we will be discussed in the previous slide, while the other sine, cosecant, tangent and cotangents are negative because in the fourth quadrant x is positive and y is negative. If the x is positive we say that cos and secant is positive because we know cos is equal to x over r. R is always be positive and x is positive in fourth quadrant, so the only values of cos and secant is positive, the other four are negative. 115 degree is lie in the second quadrant. In second quadrant we know that y is positive and r is always positive, so the value of we know that the value of sine which is equal to y over r, y is positive in second quadrant, so the value of sine and cosecant is positive and the other four values are negative. 190 degree lie in the third quadrant. In the third quadrant only tangent and cotangent are positive while the other values are negative, because we know that in the third quadrant x is also negative and y is also negative, so the value of cos and sine both values are negative because x and y are negative. Here is the example to identify the quadrant of an angle theta that satisfies the condition. First is the sine greater than 0 and tangent theta less than 0. Now we solve this and identify the quadrant. Sine theta is positive. In which quadrant sine theta is positive? In first and second quadrant is sine theta is positive, and tangent theta is negative because tangent less than 0 means tangent has a negative value. Tangent is negative in fourth and second quadrant. So check this that it is 1 and 2, this is the 2 and 4 where both conditions are satisfied in only second quadrant. Here is also have a second and it is also have a second. Uh, if we take the intersect then we know that here is also 2 and here is also 2. This is this condition is satisfied only for the second quadrant. Now in the Second condition, cos less than 0 and secant less than 0. We know that cos is negative in second and third quadrant and secant is also in second and third quadrant. So the condition is satisfied either in second quadrant or in third quadrant. Now for the third part of the example, secant less than 0, sine less than 0. Secant is negative in second and third quadrant because x is negative in second and third quadrant, and sine is, here is the less than 0 mean sine is negative. Sine is negative in third and fourth quadrant. As here you can intersecting both values, we get only the third quadrant, that this condition is satisfied for the third quadrant. And here is the part 4. Cos theta is positive in 1 and third quadrant and cosecant is positive is 1 and second. So by intersecting both conditions, we know that the given condition is satisfied for the first quadrant, because by intersecting both first and third and first and second, we get only the first quadrant. Here is the example that find the values of trigonometric function. Here is given that sine theta is equal to 2 over 3. As we find the values of the other 5 trigonometric function, we know that the reciprocal of the sine theta is 3 over 2. It means that the reciprocal of sine theta, which is the cosecant theta, by reversing the value 2 over 3, which is equal to 3 over 2, we have other 4 values. As by comparing that sine theta, which is equal to y over r 2 over 3, it means the value of y is 2, the value of r is 3. This is by using the Pythagoras theorem, which is equal to x square plus y square, which is equal to r square, or distance formula. You can also say that distance formula. We do not have the value of x, so we here determine the value of x as usual, x square plus by putting the value of y, which is equal to y square, and substituting the value of r, which is equal to 3. So here is the square root of 3, square of 3 is 9, and the square of 2 is 4. So by subtracting both values, we have 5. X square is equal to 5. So we have the two values for x. X is equal to square root 5 and x is equal to minus square root 5. So here is in the given condition that angle is in the second quadrant. So in second quadrant x is negative, so we select the value of x, that which is equal to minus square root 5. So while substituting the values as that, we know that cos is equal to x over r, and we have the x value of x, that square root 5 over 3, and the reciprocal identity of cos is secant r over x, which is equal to 3 over minus square root 5, and the tangent y over x, we have the value of y here 2, and determined value of x is minus square root 5, 2 over minus square root 5, by reciprocaling the value of tangent, which is equal to cot theta. Now this is another example that sine theta is equal to 12 over 13, and the terminal arm is in first quadrant. Find the other values. As we already know that the trigonometric identities, this is another method to determine the values by using the Pythagoras identities or basic trigonometric identities. By substituting the value of sine theta here, which is equal to 12 over 13, so 12 over 13 square plus cos square, which is equal to 1. 1 minus 144 mean square root of 12, and here is the square of 12. 12 square is 144 and 13 square 169. This implies that the value of cos theta, by taking the LCM, 169 minus 144 over 169, which is equal to 25 over 169. We have two values of cos theta. Square root of 25 is 5. Square root of 169 is 30. One is cos is has a positive value and other cos has a negative value. But here is the given condition that angle is in the first quadrant. So in first quadrant all the trigonometric functions are positive. So we select the value cos theta is equal to 5 over 30. So here is the value of cos, that 5 over 13. The reciprocaling the value of cos is equal to secant. It is 5 over 13, then this value is 13 over 5. We know that the quotient identities, we use here quotient identities for the tangent theta, which is equal to sine theta over cos theta. The value of sine is given, which is 12 over 13, and the value of cos that we have find here 5 over 13, which is equal to 12 over 5. By cancelling the 13 by 13, 12 over 5. Quote, it is the reciprocal identity of tangent theta. The tangent has the value of 12 over 5. The quote has the value 5 over 12. This is the example 5, verifying the following. This example is related to the determining the value of the trigonometric function sin 60 cos 30 minus cos 60 sin 30, which is equal to sin 30. Second question is 2 sin 45 degree plus 1 over 2 cosecant 45 degree, which is equal to 3 over square root 2. The third question is sin square 30 degree plus sin square 60 degree plus tan square 45 degree, which is equal to 2. So we solve the first here. By verifying both, we consider left hand side first. The left hand side sin 60 cos 30 minus cos 60 sin 30, substituting the value of these from the table of the values that we already seen in the previous slides, and determine that how can easily be we make a table for the trigonometric. How using 0 to 4, then dividing the 4 for every value, 0 over 4, 1 over 4, 2 over 4, 3 over 4 and 4 over 4, then square rooting the values. You can also draw the table for here. The value of sin 60 is square root 3 over 2 and the cos 30 is square root 3 over 2, same. The value of cos 60 is 1 over 2. The value of sin 630 is 1 over 2, because both angles are complement, and here is also both angles are complement to each other. Square root 3 multiplied by square root 3, which is equal to square root 3 square root, and square of square root 3 cancel each other, so we get 3. 2 into 2, which is equal to 4. 1 into 1 1. 2 over 2 into 2 4. 3 by 4 minus 1 by 2, which is equal to 2 by 4 1 by 4. And by using the right hand side is also sin 30. We have the value of sin 30 is 1 over 2. So left hand side is equal to right hand side, hence proof. Here is the second, that 2 into sin 45 plus 1 over 2 cosecant 45, substituting the values that sin 45 has 1 over square root 2 plus 1 over 2 as it is, multiply by cosecant 45. The reciprocal, the value of sin 45, will get the cosecant 45, multiplying and simplifying 2 over square root 2 and square root 2 over 2 by taking the LCM. 2 square root 2, 2 square root 2, 2 multiplied by 2 4, and square root 2 into square root 2, square of square root 2, square root, square and square root cancel each other, 4 plus 2, which is equal to 6, and 2 square root 2 is similar by cancelling the 6 by 2, which is equal to 3 over square root 2, which is the right hand side. Now this is the third example, third part, which is we consider the left hand side sin square 30 degree, sin square 60 degree and tan square 45 degree. The value of sin 30 is 1 over 2. Here is the square, so we put the square for the value of sin 30. Similarly, we do this for sin 60, tan 45, we have only value 1. By squaring all these values, 1 over 4, 3 over 4 plus 1, 1 over 4 plus 3 over 4 which is equal to 4 over 4 plus 1. 4 cancel out with 4 which is equal to 1. 1 plus 1 is equal to 2. Now you can solve other example related to these by using your handbook that you are studying in your class and in your college. Thank you for watching this lecture. If you have any query, any question, then uh, ask me the question in the comment box. Thank you for watching.